Okay, in this first example, we have a function and we need to find the x-coordinates of all the critical points and if it has any discontinuities, but it's a polynomial, so it will not. And then we need to find the open intervals where the function is increasing and decreasing. So remember, you're going to take the derivative, set it equal to 0, find the x values, and where there are x values, that is where you're going to have critical points. And then you're going to draw a number line, and then you're going to find the intervals using those critical points. And or for rational function, you'd find asymptotes. Then you're going to create a table and number line to, ended up erasing the W. You're going to show the info. So let's get started. So I should have, okay. So we have our function, we take the derivative, negative 4x cubed plus 4x, and we're going to set that derivative equal to 0, and I'm going to factor out each of these share of 4x, but I'm going to factor out the negative in front. So when we do that, remember when we put parentheses, we force the sign to change on the inside. And what I notice is that this right here is a difference of squares. This can be factored to x plus 1, x subtract 1. And actually, I'm now going to change that to that. So then we have our critical point. Our critical points. This x value right there will be 0. The opposite of 1 is negative 1. The opposite of negative 1 is 1. So here are our 3 critical points. And down here on the number line, I created a number line with those 3 critical points. All right, so now we have our intervals. So we have negative infinity up, this is a open interval, up to negative 1. Then we have between negative 1 and 0, between 0 and, oh, that's goofy of me, between 0 and positive 1. And from 1 to positive infinity. So we have 4 intervals there that we have to deal with. So I'm going to, and I had done an earlier problem and forgot to change this, so we need to change all of those. Sorry about that this is going to take a minute. Okay, those are our intervals, and now we have to choose a point within each interval, because when we choose a point, we're going to then input the points into each of those x's, and if whatever the sign is, that's what we're going to put here. So between negative infinity all the way up to negative 1, the easiest number that I can think of would be negative 10. Between negative 1 and 0, that's going to be a fraction. I'm not going to like that. Would be negative 1/2. Between 0 and positive 1, that now looks like a 2, but between 0 and positive 1, I'm going to use positive 1/2. And from 1 to positive infinity, I'm going to choose 10. And that's what we did there. Okay, so now you just take those, and we're going to plug negative 10 into each of those. Well, negative 10 cubed, it's an odd exponent, so it will be negative. Negative 1,000 times negative 4, that's positive 4,000. Doesn't matter if this is negative. This small negative number plus this large positive, this is going to be positive. It's going to be increasing right there. So this is how we mark up the number line. We do that. All right, now we're going to plug in negative 1/2. All right. So negative 1/2 cubed is going to be, let's see, negative 1/8 times negative 4. We're going to get positive 1/2. When we plug negative 1/2 into 4x, we're going to get negative 2. Well, when you add those two things together, this is going to be a negative number. So it's going to be decreasing. So we plug positive 1/2. Well, this is going to be negative 1/8. We plug positive 1/2. That's going to be positive 2. Oh, look at this 2 is much bigger than negative 1/8. So we're back to positive. That's increasing. And when we plug positive 10 in, that's going to be a very large negative number, so we know this is going to be negative. And these are the table. The next one we're going to be, one of the future videos will be, the reason this is important is it helps us decide if we're going to have minimum or minimas or maximas at these critical points. So we'll get to that later, but for now, this is how you show me the behavior of a function, intervals of increasing and decreasing behavior. That's it.